First of all, let's establish the fact that partial fractions is the reverse process of adding or subtracting fractions. Let's say, for example, I have 3 over 4. Now I need to find the fractions which will give me 3 over 4. In this case, it can be, let's say, for example, 1 over 4 plus 1 over 2, or 3 over 4 can also begin by 1 over 4 plus 1 over 4 plus 1, or it can also begin by 1 minus 1 over 4. So in this case, I have multiple possibilities. But when I'll be given a partial fraction question, it will involve a rational fraction. That is, both the denominator and the numerator will be a polynomial. And why do we use partial fractions? So we use partial fractions because the expression becomes simpler to integrate or differentiate, or maybe just simply analyze. And there are two main methods to solve partial fractions. The first of which is comparing coefficients, which you might be familiar of, and the second method is a shortcut derived from the first method. That's called the cover. First of all, let's look into the first method. I'll copy this and I'll paste this. So now, how do we apply the cover? We'll take an example. Let's say, for example, I have 3 over x minus 1 x plus 2. So in this case, realize that the denominator is in factorized form. If it's not in factorized form, I'll have to convert it in factorized. So how do we convert this into the its components? Like which fractions will give me this fraction? So in order to do this, I'll write this as a over the first bracket x minus 1 plus b over the second bracket x plus 2. Now in order to make this a single fraction, I'll multiply both sides. So we have the same denominator. That is, I can write this as, just a second, x minus 1 x plus 2, and a multiplied by x plus 2, and b would be multiplied by x minus 1. And on this side, I'll have the same thing. That is 3 over x minus 1 x plus 2. So now realize that the denominators will cancel off, and I'll do that. So the denominators cancel out. So now I'll be left with a x plus 2 plus bx minus 1 is equals to 3. I'll expand the fractions. So I have ax plus 2a plus bx minus b is equals to 3. I have 3 is equals to x multiplied by a plus b plus 2a minus b, which is the constant part. I group the terms together according to x, or if they're constants, so I can compare the coefficients. So on the left hand side, I have no term with x, so I'll ignore this part and I'll start with this, the constant. So I can write this as 2a minus b is equals to 3. And I have two variables, so I do need a second equation. So I can write using this the second equation as x a plus v is equals to 0. The x's cancel out and a plus b turns out to be 0. And thus a is minus b. So I can substitute a as minus b into the first equation. Thus I can write this as this. That is minus 3b is equals to 3 and b turns out to be minus 1. Consequently, when I substitute this into the second equation, I have a as 1. And once you have both the values, realize that we cannot leave our answer in this form. We have to leave our answer as partial fraction. So I have 1 over, what was it? Yeah, x minus 1 plus b is minus 1. So I can write this as minus 1 over x plus 2. And this, my fellows, is my answer. So a second example, the last one for this method. Let's say, for example, I have pi x minus 3 over x minus 3 x plus 2. So again, I have two brackets, two things being multiplied in the denominator. So I can write this as a over x minus 3 plus b, that is something, over x plus 2. So in order to convert this into a simple fraction, I can write this as, just a second, in the denominator I'll have x minus 3 multiplied by x plus 2. Thus in the numerator I'll have a multiplied by x plus 2 plus b multiplied by x minus 3. That is, I just cross multiply. And on this side the expression remains the same. I'll just copy this now. And you realize that the denominators cancel off. Thus, I am left with 5x minus 3 is equals to ax plus 2 plus bx minus 2. I'll expand the brackets and group the terms together according to the respective variables, matching powers of x. So I have ax plus 2a plus bx minus 3b. This remains the same. And I have x a plus b plus 2a minus 3b. And thus I can form two equations. That is, I'll compare this thing with this thing and minus 3 with this thing. So I have pi x is equals to x a plus b. The x's cancel out and I have a plus b is equals to pi as the first. And appreciate the fact that whenever I have two variables, we usually have to solve that. And for the second equation, I have 2a minus 3b is equals to minus 3. So from equation 1, I have to write this. From equation 1, I have a is equals to 5 minus b. This is my equation 3. This was my equation 2. I substitute equation 3 into equation 2. So I have something like 2 pi minus b minus 3b is equals to minus 2. And I have 10 minus 2b minus 3b is equals to minus. And I have something like minus 5b is equals to minus 30. And minuses cancel out, thus I have b as 13 over 5. And I'll substitute it back into equation 3 to find a. So I have 5 minus 13 over 5, and a turns out to be my friend 12 over 5. I cannot leave my answer in this form, thus I'll have to write my answer as, just a second, 12 over 5, the denominator is x minus 3, plus 13 over 5, the denominator is x plus. This is my answer.